What is this bridge made of?
The bridge is made of metal.
Why do they use metal for making bridges?
Well, in olden times, people made bridges and buildings with wood. But none of these bridges and buildings lasted long. Structures that are made of metals or use metals to form the skeleton of the structure are strong and durable. That's one of the reasons why metals are used so widely for making almost everything that we see around us. In this lesson, you will learn about metals. By the end of this lesson, you will be able to list the uses of metals, list the physical properties of metals, and list the chemical properties of metals. Metals are used in making machinery, automobiles, aeroplanes, buildings, trains, satellites, gadgets, cooking utensils, water boilers, etc.
Are all metals hard, strong, and durable solids?
No. Sodium and potassium are soft metals that can be cut with a knife. And mercury is a liquid metal.
A liquid metal. Can metals be gaseous too?
No. There are no gaseous metals.
Dad, why are those thick wires carrying electric power made of metal? Is it because the wires need to be very strong?
Yes. Those wires need to be strong. But there is a more important reason why those wires are made of metal. You see, metals conduct electricity very well. Non-metals don't. That is the most important reason why wires that carry electricity are always made of metal. Haven't you noticed the wires attached to all electrical and electronic gadgets, such as toasters, television sets and computers?
Speaking of gadgets, why is the base plate of an electric iron made of metal? It is not supposed to conduct electricity.
The metal base in an electric iron is for conducting heat, not electricity. Metals are also very good conductors of heat too. That's why cooking utensils, irons, heaters, etc. are all made of metals. Besides, metals can be easily shaped into wires. This property of metals is called ductility.
Dad, what is that man doing?
He is a blacksmith, and he is hammering the red-hot piece of metal into a flat tool. Metals can be easily shaped into thin flat sheets. This characteristic of metals is called malleability.
Ah, that explains this aluminium foil that Mom uses to pack my lunch in. Dad, look at those shiny bells in the temple. Are those made of metal too?
Yes. All metals make a sound when struck with hard objects. And most metals can be polished to a shiny appearance. That's why gold and silver jewelry shine so much.
Dad, how do I distinguish metals from non-metals?
Well, as we just saw, things made of metal typically are sturdy, can be polished to a shiny finish, are good conductors of electricity and heat, can be drawn into wires and beaten into thin sheets, and produce a sonorous sound when struck with hard objects.
Dad, why has this iron rod turned like this?
It's rusted. Iron reacts with atmospheric oxygen and moisture to form iron oxide, which is commonly known as rust. Metals react with other elements in a variety of ways. Metals burn in the presence of oxygen to form metal oxides, which are basic in nature. For example, if you burn a strip of magnesium, magnesium will burn in oxygen to form magnesium oxide. Magnesium oxide dissolves in water to form magnesium hydroxide, which is basic in nature. Similarly, when a copper vessel is exposed to moist air, a green coating forms on its surface. The coating formed is a mixture of copper hydroxide and copper carbonate.
At last, I found them.
What are these? Oh, iron nails.
These nails got rusted too.
Yes, the nails have rusted because of the moisture present in air. Metals react with water, but all metals do not show the same kind of reactivity. For example, sodium reacts vigorously with water and oxygen and produces so much heat that it catches fire. That's why sodium is stored in kerosene, to prevent it from coming into contact with moisture and oxygen. Let's try an experiment. Take a trough. Fill half of it with water. Now, carefully cut a small piece of sodium and dry it using a filter paper. Then, wrap it in a small piece of cotton. Place the piece of sodium in the water trough. You will observe that sodium reacts vigorously with water, catches fire and moves about in the water, making a hissing sound. Now, touch the trough.
It's hot.
So, now you understand how much heat was produced in the reaction. When you introduce a red litmus paper, it turns blue, indicating that the solution formed is basic in nature. Be careful. You should stay away from the water trough during the reaction. It gets very hot.
What are you doing, Father?
I'm cleaning this tap with a lime peel. The tap is looking dull because of the deposits of calcium salts in water.
Ah, the tap is shining now. How did that happen?
Lime juice contains citric acid. Acids react with salts of metals. The citric acid of the lime juice reacted with the calcium salts on the tap, and now the tap is clean. Metals react with acids, such as hydrochloric acid and sulfuric acid, to give out hydrogen gas. Let's try an experiment to understand how this happens. Let's take 4 different metals: magnesium, iron, aluminium and copper in 4 different test tubes A, B, C and D respectively. To these test tubes, we add 5 milliliter of dilute hydrochloric acid or sulfuric acid using a dropper. We now heat the test tubes gently using a Bunsen burner. Hydrogen gas is liberated. But how do we know it's hydrogen? To test the gas, we introduce a burning splinter near the mouth of the test tube. The splinter is put off with a pop. It shows that the gas is hydrogen. From this, we can conclude that metals react with dilute acids and liberate hydrogen gas.
Do metals react with bases in the same way that they react with acids?
Yes, the reactions are quite similar. Metals react with bases, such as sodium hydroxide, to produce hydrogen gas. Let's verify this with an experiment. Prepare a fresh solution of sodium hydroxide in a test tube by dissolving 3 or 4 pellets of it in 5 milliliter of water. Into this solution, drop a piece of aluminium foil. We now bring a burning splinter near the mouth of the test tube. The splinter is put off with a pop. This shows that hydrogen gas was produced.
Indeed, the reactions of metals with acids and bases are quite similar. But Dad, you mentioned that some metals, such as sodium, react more vigorously than others. How do you know that?
Let me show you an interesting experiment. Let's take 5 beakers, A, B, C, D and E. Let's take copper sulfate in beaker A and B. Drop some zinc granules in beaker A and iron filings in beaker B. Take zinc sulfate in beakers C and E. Drop copper turnings in beaker C and iron filings in beaker E. In beaker D, take some ferrous sulfate solution with a few copper turnings. Now, note that the blue color of the solution in beaker A has disappeared. This is because zinc replaces copper from copper sulfate. In beaker B, the solution turned green. This is because iron has replaced copper from the copper sulfate solution. There is no change in the other 3 beakers, C, D and E. This brings us to the end of the detailed session on metals, their appearance, behavior and uses in our day-to-day life. Now, you should be able to describe the physical and chemical properties of metals and list their uses.